Good.
Okay, maybe we can start. Good afternoon to everybody. The title of the seminar today is Chemistry, Duality and Complexity of Science, and it is presented by Professor Francesco De Angelis. Francesco De Angelis retired for age limits in 2019. In 2020, was nominated honorary professor at the University of L'Aquila. Doctor of Chemistry in 1974 at University Sapienza of Rome with a thesis in organic chemistry, he was a researcher there for a few years. He joined the faculty at the University of L'Aquila in 1987, first as associate professor and then as full professor of organic chemistry. He was the founder of the mass spectrometry discipline at this university. His research interests ranged in the field of organic reactions, natural compounds, and organic and bioorganic mass spectrometry. Professor De Angelis was a member of the editorial boards of prestigious peer-reviewed chemistry journals. He was president of the Italian Chemical Society and served the European chemistry associations like EUCHEMS as treasurer, ECTN as president, and Chemistry Europe as a member of the council. He got honors in his career, among which the gold medal Domenico Marotta by the Italian Chemical Society and the EUCHEMS Award for Service. So when you are ready, Professor De Angelis, you can share your screen and start the presentation. The floor is yours.
Let me try to. There it is.
Okay.
Is the screen here for everybody? I think so.
Yes.
I have a few. Okay. Here we are. So thank you so much, Sarah, for your very kind introduction. And let me thank first the TMS and also Sarah Battista directly for their kind invitation to the TMS presentations. Good morning, everybody. I'm very delighted to see you all with during this webinar, where I will address the problem of the duality and complexation of chemistry. I think that everybody knows that today, the 27th of January, is the International Holocaust Remembrance Day. And I would like to honor the Shoah by starting my presentation with citing one of the most important Italian writers, Primo Levi, and citing his preface of the book, The Two Faces of Chemistry, which was published by Luciano Cagliotti something many years ago in 1979. And the Primo Levi says something that is directly related to the topic of this presentation. He said that today, by some thinkers and many non-thinkers, the same scientific and technological progress is questioned. The Industrial Revolution caused two planetary and bloody wars. From chemistry came dynamite. From Einstein and Fermi came Hiroshima. Seveso came from herbicides. From tranquilizers, the tragedy of thalidomide. From dyes comes cancer. That's enough. Let's stop. Let's go back. This is the suggestion, but what is the answer by Primo Levi? The answer that I absolutely agree on. He says, now you can't go back, or you can, only at the expense of a massacre of unprecedented proportions. Going back to their origins would mean reopening the doors to epidemics and infant mortality, renouncing the production of chemical fertilizers, thus reducing the agricultural production and condemning hundreds of millions of individuals to starvation, in addition to those who at present already suffer. So where is the solution to this problem? He says, it is necessary to face the single problems one by one with honesty, intelligence, and humility. This is the delicate and formidable task of today's and tomorrow's technicians and politicians too, I would like to add. Is chemistry a dual science, and in which sense? In my opinion, the duality of chemistry resides in the intrinsic nature of the two sides of one coin. Is chemistry pure and at the same time impure? Chemistry gives benefits, but also some detriments and risks. Duality is something different from dualism. Dualism is a way of understanding reality and knowledge based on an essential doubleness. For chemistry, we can simply speak of dualism regarding simply things like theory and practice, research and development, laboratory and industry, and so on. But the duality is something different. It may appear to be a dualism, but unlike a dualism, the two elements in it are interdependent. They are two sides of the same nature. They cannot be separated. They are not opposite, while remaining conceptually distinct. Otherwise, the duality would result into unity. What's my opinion? Do I agree with something which is a common knowledge or a common opinion? Is chemistry an impure science? Actually, this point of view has been very clearly put forward a few years ago, in 2008, by Bensal, Vincent, and Simon. They justified their characterization of the science of chemistry as impure on several grounds, including its multiple service roles, its intrinsically close but messy relationship to the society and economy of which it is a part, its association with pollution and poisons, of course, I agree with this, its position in the middle of the positive scientific spectrum, coming back to the second half of the 19th century, and its perennial failure to derive its logical base from abstract principle or mathematic axioms, like it is the case of physics. Let me just spend a couple of seconds on this last opinion. Actually, chemistry cannot be directly related to basic principles or mathematical axioms. Chemistry, to some extent, a difference from physics or medicine or other sciences. Chemistry is, to some extent, is close to arts. Chemistry actually studies its own production. Chemistry creates molecules and then studies molecules. So to some extent, there is a sort of relationship between, in my opinion, chemistry and arts. Again, I think that it is not immediate to portray a complex science, such as chemistry, in a clear and convincing way, capable of enlightening the object of study. While dualism in chemistry, as has been already said, presents a clear-cut simplicity, everybody understands the difference between theory and practice, for instance. The duality concept, in my opinion, changes according to cultural awareness, times and places, history and geography, peoples and politics. It is difficult to design a general context that is independent of other subordinates with conditional values like politics, peoples, geography, history, places, times. But very fortunately, we live in an historical area nowadays, and there are efforts now to carry out, to introduce, that have been carried out to introduce through laws and regulations at the local or continental or even world level, but above all through the elevation of social consciousness guided by ethical principles, to introduce structural elements and boundaries that recognize, orient, and limit the duality of chemistry towards horizons only beneficial for humanity and nature. Is chemistry at the same time pure and impure? We try to give an answer to this question. Very clearly, in chemistry, there are fertilizers. This is a pure side of chemistry, but chemical weapons, that's the impure side. There are plastics, but plastics have a very profound impact on the environment. There are accidents in chemistry plants. Pharmaceutical chemicals are absolutely very, very, very good for human health. Let's start with the first example along a number of cases that I am going to treat. This is an historical case. The case of Fritz Haber, who discovered the synthesis of ammonia in 1909 in his lab. The synthesis of ammonia starting directly from nitrogen and hydrogen to give ammonia over a catalyst. This synthesis was then transplanted into industry, into a plant with Karl Bosch, a chemist from BASF in 1913. And Fritz Haber, for this discovery, was given the Nobel Prize in 1918. Absolutely, no doubt, the discovery of ammonia synthesis from nitrogen and hydrogen is considered one of the most important reactions for humanity, because it allowed the production of nitrogen fertilizers at low price and in higher amounts. After its discovery, the world population has increased dramatically from 1.7 billion at the beginning of last century to 8 billion counted just a few days ago. Without fertilizers, world food production would not be sufficient to guarantee the sustenance of human species. Take note that fertilizers, before the Fritz Bosch reaction, only came from animals. Note also that on the other hand, on the other side of the coin, this reaction is also used for the production of explosives and gunpowder. You can see here a huge BASF plant for the production of ammonia in Texas. Its production capacity was just below 1 million tons per year in 2017. In 2019, the global production of ammonia was about 150 megatons. It's a huge production. Let's go back to Fritz Haber in person. As I said, he was a brilliant chemist of last century. He was very, very good. And because of his competence in chemistry, he was also given the duty to guide the German forces against the Allies, against the France forces in Belgium. And he was the first to adopt chemical weapons. He was guiding the German troops. He adopted the chemical weapons, in this case chlorine and phosgene, to attack the enemies. 6,000 cylinders were placed on the front. They were opened the 22nd of April 1915, and almost immediately, because of the gas that went in favor of the wind, in favor of the German troops and against the French, Algerian, and Canadian troops, more than 6,000 people died almost immediately. This was the first use of chemical weapons during a war, the first massive use, even if already the chemical weapons have been already banned by the Den Haag Protocol before the First World War. Not only in that case, but just only 2 years later, in 1917, in July, and again at Ypres in Belgium, the German troops, this time guided by these two generals, were using another chemical weapon. The current name of this is mustard gas, later called Yperite because it was used in Ypres. Mustard gas because of its smell. It's a liquid, reasonably volatile. They were used using bombs. What is the effect of this liquid? You can see the effect of the liquid on an arm of a person. But when this liquid is inhalated, after a couple of days, the person eventually dies because of a terrible inflammation of the respiratory channels. This is the formula, the chemical formula of this terrible compound. You can see that the chemical precursor of this, which is called thiodiglycol, it has two OH groups instead of chlorine. I'm going to mention thiodiglycol. Many years after the First World War, in Iraqi, this compound, the mustard gas and other gases, the nervine gases, were used by the regime of Saddam Hussein for killing thousands and thousands of Kurds in northern Iraq. The precursor of the mustard gas, which is the thiodiglycol, you will see it indicated by the arrow with the asterisk, was sold to the Saddam Hussein regime by an industrial chemist, Dutch industrial chemist, Frans van Haaraert. This was in 1989. This guy was arrested because of, and then condemned to 17 years in prison for war crimes. He pretended to say that he believed that this chemical, thiodiglycol, sold to Saddam Hussein was just sold because to be used in the Iraqi textile industry, which is clearly a lie. But fortunately, nowadays, we have a very strong, powerful, but also a high-level organization, which is the Organization for the Prohibition of Chemical Weapons. This organization sent around a convention in 1997. And this convention was signed by 193 states over 197 that are classified in the UN, United Nations list. These states committed and signed the Chemical Weapons Convention, which was sent out just to achieve the vision of a world free of chemical weapons and the threat of their use, in which chemistry used for peace, progress, and prosperity. 98% of the global population live under the protection of the convention, and 98% of the chemical weapons after 1997 have been verifiably destroyed. 4 states did not sign this agreement. The organization for the OPCW was given the Nobel Prize in 2013 for its extensive efforts to eliminate chemical weapons. Not only, but this organization in 2015 organized a meeting in Ypres in Belgium to celebrate the 100 years of the first massive use of chemical weapons in Ypres. And European chemists were there, led by 3 gentlemen. One is the president of the Royal Society of Chemistry, or was the president of Great Britain, and then the president of the German Chemical Society, GDCH, and also the president of the European Association for Chemical Sciences, David Cole Hamilton. And the press release says that UCAMS stands beside all right-thinking people in deploring chemical weapons and calls for their complete elimination in all countries. Israel is one of the 4 states that did not sign the Convention on Chemical Weapons. And the Yud Kainan, who still is the president of the Israeli Chemical Society and is the president-elect of the IUPAC, the most important organization at the world level in chemistry. And he sent a letter to Netanyahu, who was the president of the Israeli government, and he says, we request that the government of Israel will independently ratify the CWC, Convention on Chemical Weapons. We have no doubts that Egypt, the second country, will quickly follow this move and join the convention as well, because nobody would like to defy a global consensus and remain on the wrong side of the fence together with North Korea, the third one. The fourth is South Sudan. Only 4 countries until now have not signed the Convention for Chemical Weapons. Let's move on a different topic where we see the benefit and the risks of chemistry. Everybody knows that plastics is something of a problem nowadays. You can see that polyethylene, one of the most used plastics, is used for water bottles or drinks bottle. It's spread all over the world. You can see in the low part of the slide, in Africa probably, where they try to destroy the plastics or bottles, and also in Rome some weeks ago. Other plastics that create problems to the environment are polyethylene in this double format, high density and low density, polyvinyl chloride, which is one of the worst plastics, polypropylene, which is one of the best because it's used in very many tools that we nowadays, every day, day by day, we use in our homes, and polystyrene, and also, of course, synthetic rubbers. Polypropylene is the most famous one. We in Italy know it as Moplan. And we remember, of course, the Carosello many years ago with Gino Bremieri, and my mom blend and so on. And the polyprene isotopic propylene was invented at the beginning of the 50s by Giulio Natta because he used the new titanium catalyst discovered by the German scientist Carl Ziegler. Both of them were awarded the Nobel Prize in Chemistry in 1963. Isotopic polypropylene was very highly innovative in terms of mechanical strength and cost effectiveness of production. And it was produced, at least at the beginning, in Italian industries. But this is the side effect of plastics all over the world. Plastics cannot be destroyed easily. They cannot biodegrade. They accumulate on soils, groundwater, and seawater. And everybody knows the big problem of the Pacific plastic islands that covers, somebody says, less than 1 million square kilometers. But according to other sources, it even reaches a surface which is almost the same as the entire North America or even Western Europe. More than 15 million square kilometers. It's a problem. It's a problem that we are going to try to limit to some extent. We probably know that a couple of weeks ago in Italy, it was launched a legislative decree 196 that says that in Italy it will no longer be possible to produce the single-use plastic. What we call the le plastiche, the usa e getta, to use and to throw away plastic plates and cups, ear sticks, straws, containers, glasses for food and drinks made of expanded polystyrene. That is, plastics that are not biodegradable and not compostable. And this decree follows directly the European Euro Directive SUP, single-use plastic, that was launched in July 2019. Take note that in Italy, between 6 and 7 billion of disposable plastic cups are consumed per year. That is between 16 and 20 million objects per day. The objective of the European strategy for plastic is to ensure that by the 2030, all plastic packaging placed on the union market is reusable or easy recycled. The question that remains is the following: is the weight of bioplastics or disposable paper tableware more respectful of the environment? We're not going to address this question now. This is probably what is in front of us if we do not take the correct measurements. Let's change to insecticide and the impact on the environment. What you can see here is a picture taken in the early 44, immediately after the Allied landing in Anzio, south of Rome, during the Second World War. It says, malaria precautions, get fully clothed by sundown. That means that it's an alert to the Anglo-Saxon, to the Anglo-American soldiers. Take care, because this is a malarian area. The same in Italy was for the Venice area and also South Sardinia. But the Anglo-Americans brought with them the DDT that was used in the United States since the 30s with the name of flit. It was a famous arch enemy of flies. It is a famous arch enemy of flies and mosquitoes. You might, in the States, they used to say, hurry up, Henry, come with the flit. The flit destroys flies and mosquitoes. And with the flit, the DDT made it possible to eradicate malaria transmitted by the mosquitoes. This was the case of Italy, Europe, and North America. DDT has been successfully used against typhoid fever and other diseases transmitted by endemic insects in tropical areas. And DDT was also used as an agricultural insecticide after 1945. But in any case, DDT was banned in many countries. Now we have substitutes. Since 1970s, not all countries, in Africa and South America, it is still used just to combat malaria. It was banned due to its persistence in the soil, slow biodegradability, and its biological effects. There are serious consequences of the insecticide along the food chain. It accumulates in fatty tissues with consequences of bioaccumulation, that is biological amplification. We cannot avoid to mention the accidents that affected the chemistry plants. The fault of this, to some extent, might be of chemistry, but to other extents should be given to the industrialists and to the politics. But nowadays, fortunately, the situation is much more secure than in the past. The first one, which was really very, very important all over the world, that gave also rise to what is called the Seveso directives. That is how to defend by situation like this. In Seveso, on Saturday, just before the weekend, where the plant was going to be closed and reopened next Monday, the plant unfortunately went up with temperature and pressure and exploded at 12:35 p.m. The plant was located 25 kilometers north of Milan. And you can see in the pictures of what happened. The trichloropheno, which is a component of several herbicides, it was the product of this plant actually started to react with itself. And what the production was the release of dioxin or dioxins, which are very, very poisonous molecules that affect the human beings, not only, but also other living systems. According to a sort of ranking, this has been defined as one of the eight worst environmental disasters in history. One of the worst was a few years later, in 1984, in Bhopal. They produced there at the Union Carbide plant methyl isocyanate, which is a product for the synthesis of pesticides, polyurethanes, and plastics. At the time, the methyl isocyanate was accumulated in the reactor to be sold. All of a sudden, because of some failure of the plant, the reactor exploded. And you can see there on the picture the crowd of the methyl isocyanate on the city. Almost immediately, almost 40,000 people died. But according to the government in that city of India, almost probably 50,000 and 20,000 victims were the consequence of this explosion. Nowadays, methyl isocyanate, as soon as it is produced, is immediately used for the following reactions. It cannot be accumulated anywhere. Let's go to something less scaring. Let's go to something which is the green part of chemistry, the invention and production of antibiotics. You can see there the formula of penicillin, which was discovered in 1928 by Fleming, but was first used only 15 years later, on March 14, 1942, by the physicians that were treating Ann Miller, a lady, which had a very high fever for several days because of a bacterial infection. She was saved by penicillin, and this was the first event, and from them the antibiotic era started. And Miller died many years later. Let's note that at the beginning of the last century, people lived on average up to 50 years. Now we can reach, hopefully, 80 years at least. In 1943, the many kinds of influenza and bacterial disease fatally affected 60 children out of 1,000. Now the mortality for these diseases is close to zero. And all this is thanks to penicillin, to and streptomycin and other antibiotics that have been used since after the Second World War. Just a very curious example, very curious note. Penicillin arrived in Italy in 1944 with the Anglo-American troops. And a medical historian says that the soldiers, while the soldiers went up to our country, the effects of the new drug on the population were seen. At a certain point in Milan, people were still dying of pneumonia, but in Naples they did not. That's interesting. What is the other part, the other side of the coin as far as the antibiotics is concerned, is the antimicrobial resistance. Actually, this resistance of antibiotics that is going to become a very important problem for the use of antibiotics is not due to the molecules themselves, it's due to the misuse that we do with the antibiotics. They are often used to cure the viral infections where they don't work, or against non-serious bacterial infections. What is very, very bad is the wide prophylactic use of antibiotics in farms. That is the preventive treatment of animals, cows, fishes, even before some of them get sick. The antimicrobial resistance especially affects poor individuals who have little access to second line, more expensive and focused antibiotics. It has been estimated that in 2019, 1.3 million deaths are directly due to AMR, which is the combination, it is the sum of the global deaths for HIV plus malaria, and now ranks just behind a bit the COVID-19 and tuberculosis in terms of global deaths from an infection. Note that stopping antibiotic resistance would cost only $2 per person per year in the globe. Not only antibiotics, to some extent, create some problems, but also other drugs like anabolic steroids and contraceptives. They themselves or their metabolites tend to accumulate in the environment, in the soil and in the groundwater. Both natural synthetic hormones have been identified and quantified, demonstrating that they are widespread aquatic contaminants. It is the same also for the metabolites of estrogens. Estrogens are used in the pill as a pill, but their metabolites are spread in the groundwater, physiologically spread in the groundwater. And concern has been expressed regarding the entry of estrogens into the human food chain, which in turn relates to how plants take up and metabolize estrogens. I'm going to close with two other examples. Not only medicines, but also endocrine disruptors are present in the environment. These are small molecules that are present in the everyday tools that we use in the everyday life. One is BPA, bisphenol A, that is contained in food storage containers. Dioxins that are produced by waste burning. FAS, polyfluoroalkyl substances, which is the coating of the aluminum pans that we use every day. Phthalates that are present in the food packagings. PBDA that is present in furniture foams and carpets, and polychlorinated biphenyls that are present in lubricants and plasticizers. The European Commission has adopted a communication, which is the first starting point of a more efficient rule. This communication was adopted in 2018, confirming its commitment of the European Union to protect citizens and the environment from endocrine disruptors. Let's hope that something more direct will soon follow. It is worth mentioning anyway, the European Directive of 2006, the so-called REACH, which stands for Registration, Evaluation, Authorization, and Restriction of Chemicals. REACH aims to ensure a higher level of protection of human health and environment in Europe. And finally, just a mention of the drugs of abuse, like tobacco, like alcohol, but like also the synthetic drugs that are spread all over the world more and more nowadays. And in particular, the market for the synthetic drugs like amphetamines, methamphetamines, and ecstasy, MDMA, which is and also the synthetic versions of cannabis and opioids such as heroin, they runs into billions of euro per year. It should be noted that these synthetic drugs are synthesized by chemists. They are products of chemistry. Is there a solution of the problem? What are the conclusions? With a question mark. I do not think it is possible to draw conclusions. The problem of a chemistry respectful of the environment, of nature, and of those who live there, or humankind itself, it is and will remain an open topic. Issues relating to an ethical approach of the problem evolve over time. What today appears horrible to us, it is the case of chemical weapons, for example, we have seen that. In the logic of the interest of the homeland of my country, was instead considered feasible in the first half of last century. Fortunately, nowadays, no more. What is practicable today in the advanced countries of the globe, Western countries, United States, on the other hand, still appears to be a challenging obstacle where the poverty of peoples and the GDP per capita of some countries represent the first problem to deal with. This is the case of Africa, South America, and some parts of Asia. The advanced technology in the field of new materials, the progress of research in the agricultural sectors, the advancement of control techniques in the field of food, pollutants, drugs of abuse, the discovery of new medical drugs are all achievements that should make better Gaia and her inhabitants, but which often introduce new alarms and problems. On purpose, I used the term Gaia, introduced by the chemist James Lovelock in 1979. On the positive side, what can we say about chemistry? Chemistry itself can do a lot. Let me quote Margherita Venturi of the University of Bologna. By introducing new keywords such as replace, recycle, reuse, repair, do with less, which represent the great opportunity to this discipline. Surely, above all, the permanent duality of chemistry must always be managed carefully, taking, and this is my firm opinion, ethical principles as a superior framework to face the complexity of the discipline. The global adoption, and this is the other side, the other point of view, the global adoption of continuously updated laws and regulations based on the protection and safeguarding of peoples and nature must also constitute the necessary key for the correct and valuable use of the products and achievements of chemistry. Teaching at university level of disciplines such as ethics in science for the training of the new generation of chemists must be supported with all strength, together with the introduction of the chemist's Hippocratic oath, which is often spoken of, but for which little is done. Let me conclude with something which has been written 700 years ago. Fatti non foste a viver come bruti, ma per seguir virtute e conoscenza. You are not made to live like brutes, but to follow virtue and knowledge. That's all from my side today. Thank you.
Okay. Thank you, Professor De Angelis, for your very interesting and original presentation. And now it's a time of discussion. So if you have questions or curiosities, you can write them in the chat, or maybe you can do directly, as you prefer. So don't be shy.
Anna.
Professor Teti.
Yes, Francesco, thank you very much. This was an inspiring lecture, I think, especially for the young people, because we are old and we went through most of these issues, so I remember very well everything. So, however, the problem to me is not that chemist is good or bad, but it's the use of chemist that can be good or bad. And I don't want to discourage too much the young people, because as you mentioned, the life expectancy rises a lot during these last years. So we see many people that are very, very old, so meaning that not everything chemists did was so negative for humanity. On the other hand, if I have a real concern is on the demographic increase, which is a progressive increase. So we are 8 billions. So if the rate of increase is like this in the next years, very soon we will be probably 16 billions. So this is, I think that this cannot be sustained in by the world. So just too many people around. I don't know what is your opinion. So we were 1 billion at the beginning of at the end of the war, Second World War, and now we are 8 billions. So what do you think? Is this something that we can control, or the humanity will increase so much that in the end it will destroy itself?
Thank you for your observation and question. Yes, I think that this is a problem, but in the Western countries, it is clear now that with the progression in our era, I think the number of people is decreasing to some extent. So I think that at a certain point in the world, we will arrive to a plateau. The problem is that we don't know now where is the plateau. At the moment, as you said, we are 8 billion people all around the world. I don't know when it is important, but in the meantime, I think it is a problem that we as scientists should deal with, but especially it should be dealt by the politicians and the people that govern our countries. We do what we can with our technology and hopefully also with the ability to deal with the ethical problems. But the ethical problem is not only something that refers to the scientists, it's something that should drive also the decisions taken by the politicians. This is the problem. And as you said, it's a problem that at the moment there is no answer, no direct answer to this.
I perfectly agree with you. And I also agree that we need to teach the ethics in science. Yes, you're right that we need something that comes from the politicians, but as scientists and as teachers, I think that we can do something ourselves one by one. So teaching students how to deal with ethics in science, because if something can be done scientifically, it will be done somewhere in this world. Yeah, because we cannot control all humans and all scientists, as you mentioned at the very beginning of your talk. So I think that it's absolutely important to be ourselves examples of ethics.
Yes, yes. Let me just a brief a brief idea. I think that the technology is going in the last 100 years is growing very, very rapidly at a very high slope. The other parts of culture is going much slowly. I think economy, philosophy, religions, politics, they grow very slowly. They take time. They need time. Technology is very fast. It's too fast. So this is the reason why also in our courses at university, in the area of science and technology, to some extent, we should also teach the principles of ethics, philosophy, thinking, and also economics. Why not?
Yes, you're right. Thank you.
Okay, we have 2 questions in the chat. I can read them. The first is from Oriana Newman. Thank you, Professor, for a very thought-provoking seminar. I think it is very important as students, as young scientists, that we discuss these important issues and think about how we can work to be ethical in our futures. What do you think of ethical teaching universities? Do we discuss these issues enough?
No, I don't think that we at least as seen. until I was there, that is 2 years ago, the ethical issues were not taught at all. That's a big problem. We at the I say we because I was part of UCAMS for years and years. At UCAMS, I started to press people to introduce the ethical subjects in the courses of chemistry. Ethical subjects have to be introduced not only in chemistry but also in physics and the other disciplines and engineering, other disciplines of science, because the ethical issues have to they have to become part of the education of the young generation. It's not something that should arrive only at the end of the career of a person like me. It's something that should be addressed when we are very young, not only at the high school, but especially at university, where we start our career and our profession. That's something that should be dealt with at that time, in that time.
Okay, the other question is from Marco Ponsetti. Given the situation we are going through with Ukraine, I'm just wondering what is really stopping countries at war with each other from using chemical weapons? What happens to them if they do, but by doing so win the war?
That's something that we don't know, of course. There is a responsibility that of countries that might use chemical weapons. In principle, they should not have chemical weapons because they should have been destroyed. This has been verified by many commissions of the OPCW. But who knows, especially in some countries, they might store chemical weapons and use when it is the case. This was the case of Iraq I mentioned before. I don't think that, we don't know, but they might use chemical, also bacterial weapons that might be used, and that will be discovered only later, and the responsible people might be taken and condemned. But we have to do all what we can just to convince the remaining countries to sign and adopt the Convention for Chemical Weapons. I don't know if I answered your question or treated your question.
Okay, Claudio?
Hope you can hear me as well. So, Professor D'Angelo, thank you very much for the talk. My question, well, I don't have really a question. I just want to bring another point to the discussion and maybe also know your opinion about that. The point is that this problem of chemistry, of science in general, this duality, it's also difficult to foresee sometimes. So, I mean, when we do science, it's sometimes difficult to foresee eventual problem. That this is due to the complexity of nature and also of human beings. So what do you think about that? What should we do, or what we can do about that?
I absolutely agree. It is absolutely difficult to foresee what are the consequences of our discoveries. But nevertheless, I think that the experience in many areas of chemistry is so high now that it is reasonable to see what might happen if we do something, if we create some chemicals. It's not difficult to understand. I think that many people even know that, and they do that on purpose. Think about what I was mentioning about the chemists that are producing new drugs. They know what they are doing. So the problem is not just to foresee what might happen by chance, but is to educate scientists to drive and to focus their research to the benefit of people, not only just to to do something, you know, just to work for the others, not just for themselves. Let me add, for publications or for, you know, going up with their own career.
Thank you, Professor. I agree.
Maybe Anna is already there, or maybe it's the hand.
Yes, I'm here. Yes, and I wanted to comment on the previous topic. Maybe I'm pessimistic, but we really believe that signing an agreement is sufficient to keep the countries quiet in terms of the use of the weapons. I mean, the fact that there are 4 countries that didn't sign the convention is bad, but do we really think that all the others will respect the convention? The Ukraine situation now tells us that if there is some problem between countries, they will get at least close to the war, no matter if there is a convention or not.
Yeah, absolutely. Signing convention is just the starting point. Then there's the point of control, you know. But nevertheless, it is a point. If you have signed as a country, as a government, if you have signed a convention and then use chemical weapons, is something that have to be condemned all over the world by everybody and every other government in the world. If you are not signed, it's just an alert. Take care. I might use. I have not signed. It's a starting point, but nevertheless, it's not the end of the story. Of course, unfortunately.
Yes, I agree. Thank you.
Claudio?
So regarding this problem of weapons, I wonder who is deciding what is a chemical weapon? So is there a scientific definition or just a political definition? Or
I think this is in the hands of the OPCW. They have a board of scientists that control, follow, and advise. So it is in their hands. I remember some of them maybe know him. Ferruccio Trifirò, a former colleague of mine, he was part of this scientific board of EPCW. And very many scientists and chemists in the world are part of this scientific board. So I think they have the sufficient experience to decide what is a chemical weapon. Of course, any chemical substance could be used as a weapon, you know. Also this, which is a sort of, for papers, can be used as a weapon, but is not a weapon by itself. A chemical weapon should be something that is produced, is invented, designed, and produced directly as a chemical weapon. In any case, the big problem is not only the chemical weapons themselves, but are the precursors of the chemical weapons. You know, the chemical weapons is a differentiation of a line that produces herbicides and insecticides. At certain point of the sequence of reactions, there is a side part of this program that goes to the chemical weapons. So you cannot stop the production of methyl isocyanate because it can become a chemical weapon, or ammonia because it can become a chemical weapon, you know. But you have to control that the chemical weapons, that is the last part of the production line, are not produced, are not designed, are not produced, are not tested even.
yeah, but then I mean, explosives are not considered as a chemical weapons.
Yes, of course.
But they are not less cruel than what is conventional chemical weapon.
Yes, of course.
That's the political part of the story, I would say.
chemical weapons is something that can be distributed via the normal way of distribution. Sorry for this of bombs, you know, and diffuse and treat directly populations or soldiers in such a terrific way. Also, I don't know. Also in physics, there are situations like this. I mean, is the problem of a physics scientist the projectile of a gun? No. I mean, is the man that uses the projectile of a gun. So you cannot stop. You cannot stop studying the trajectory of an object. You know, I think that the problem should be shifted to the not to the chemist. The chemist might advise and behave in the right way.
Thank you.
Okay. I also have a comment about this topic. I would like to know your opinion about the fact that probably the misuse of chemistry is a contributory factor of the chemophobia that is often widespread in the actual society.
Sorry, I think I missed the point.
I would like to know your opinion about the fact that probably the misuse of chemistry
Yes,
that we talked about is a factor that can contribute to the chemophobia that is widespread in the society now.
Yeah, it is. Absolutely, it is. Yes, absolutely. You know that I was just talking about these two French scientists, probably, or you know, that commented the chemistry as impure science. Probably yes. There are some sides of chemistry that are impure. Why not? But everything has a negative, a black side of the coin and a white one. Absolutely yes.
Okay, thank you.
Welcome.
I don't know if there are more comments or curiosities. If not, I think that I can thank you, Professor De Angelis, another time for accepting the invitation and for sure for a very interesting presentation. And that's all. So next seminar will be from biology, and we will let you know the information as soon as possible. I would like to thank all of you for joining the seminar and see you next Thursday.
Thanks, everybody.
Thank you very much. Very inspiring. Bye-bye.
Thank you. Bye, everybody.
Grazie, professore. Arrivederci.
Grazie. Arrivederci. Alla prossima.